All right, today we're going to talk about laws of exponents, and hopefully this is going to be a review for some of you. Maybe you had a little bit of this in Math 1 or middle school. So I'm going to briefly talk about the different properties and what you're going to do with those exponents. So the first law that we're going to talk about is this one right here. So when your bases are alike, you add the exponents, just like it shows. You just add whatever those numbers are that are the exponents, okay? When you are, so next here, when you are dividing, you subtract. So think multiply and add go together, divide and subtract go together. When it is a power raised to a power, so we're on this one. When a variable is raised to an exponent, raised to another exponent, multiply the two exponents. So you're going to multiply those. Now, there's a trick I use that will help you remember the difference between these two, because they're similar. It's easy to get them confused when you add and when you subtract. So I'm going to go down here and do a quick example. So let's say we've got x to the fourth times x to the third. And then you've also got x to the fourth to the power of the third. So when we're right here, think about when you have two like bases. If you're going straight across from one to the other, it's almost as if you can make that plus sign. So you're going to get x to the seventh. Over here on the other one, x to the fourth to the third, you've got a power raised to another power. And so when you've got that power raised to another power, it's like you've got that multiplication there. It makes that multiplication sign. So then, of course, that's going to give you x to the 12. So that's one little trick I use to remember. Okay, so moving on. An exponent outside the parentheses is distributed to each value in the parentheses. So if it's on the outside, it's going to go to both. So you would take this a, and it's going to go to the x, and it's going to go to the y. All right, any power to 0 is always going to be 1. Negative exponents, you always move them. So if you start out with a negative exponent, you move it to the bottom. Now, what I do sounds a little cheesy, but I think of it when it has a negative exponent, it has a negative attitude. It's unhappy. So you move it to the other place to make it happy. And once you move it, that exponent goes away. So for example, if it's on top like it is right here, you move it to the bottom. If it looked like 1 over a to the negative first, it's unhappy on the bottom, it's negative. You got a negative exponent. So you move it to the top, a to the first. Of course, we normally don't put that 1 there. But you move it to the top to get rid of the negative to make it happy again. Okay? This next one here is basically, it's very, very similar to this one. These two are similar because basically anything in the parentheses is going to get that power. And then if you have a negative exponent, they flip-flop. So notice how your x went to the bottom and your y went to the top, and then they both got that power of a. Okay, so we're going to work through some examples. So for our first one here, we're just going to do 3a times negative 5. So multiply your numbers. 3 and negative 5 is going to give you negative 15, and there's nothing else to do with the a. That's it for that one. B, very similar. Multiply your 7 and your 2. You're going to get a 14. You've got x and x. So remember, this is like that first rule. X times x, you add the power. Remember, there's an invisible power of 1. So it's going to be x to the second. For C, you multiply your 4 times 7, gives you 28, and then add all your exponents of the like basis. So you've got an a to the second and an a to the fifth. So add the 2 and the 5, which gives you 7, and then for the C, same thing. Don't forget there's that invisible 1, so you'll get C to the fourth. Okay, so for D, multiply negative 4 and 6 will give you negative 24. Your x is x, and x is second. Remember, don't forget there's that invisible 1, so you get x to the third. Y, you have y to the 0, which is the same thing. That's just a 1. And so you're just going to be left with y. Whoops. Okay, so that was a 1. I was trying to mark that there. Okay, now we get into division. Now for this part, what you want to do, when you've got whole numbers, that 9/3, and there's no powers with them, just reduce that fraction. So 9/3 is going to turn into 3. Then we subtract 5 minus 3 because it's division, so we do subtraction, x to the second. Okay, same thing here. You got 15/5. Okay, those are just whole numbers, no powers there. Reduce that, you'll get a 3. Subtract your exponent, so 6 minus 4 is going to be 2. And then 2 minus 0 for the y is also going to be 2. Okay, same thing on G. You've got these whole numbers here. Now, it's a negative number, not a negative power, so don't think you have to move it. You only move negative powers. So negative 18/3 is 6. If we subtract. Now, here on this one's a little bit different with your x's because the higher power is on the bottom. So what I always tell my students is go ahead and subtract them like you normally would. Just do 5 minus 3, and you're going to get 2. Since the higher power was on the bottom, your x is going to stay on the bottom. So wherever the higher power is, that's where your variable is going to go. And then for your y, 4 minus 1 is 3. Okay, for h, reduce 4/12. So 4/12 is going to reduce to 1/3. All right, so for the x's, I subtract. 6 minus 2 is 4. Since 6 is bigger, x is going to go on bottom. Okay, get rid of that. Okay, so then for the y's, now we got negative numbers. Just subtract. Just be careful with your, rules in negative. 3 minus -1. So for your y's, you're subtracting 3 minus -1. So be super careful with negatives. 3 minus -1, well, that double negative is going to turn to a plus, and we're going to get y to the 4th. Since y is bigger on the bottom, we put it on the bottom. And z, there's nothing left to do with the z. There's nothing on top, so I'm just putting the z on the bottom. All right, so now, for example, I, we get into power to power. So a power raised to another power. Remember, it's like that multiplication symbol. 4 times 2 is 8. Okay, on J, the 3, the power of 3 goes to the 5 and to the x. So we have 5 to the 3rd. Power to a power, remember we're multiplying, is going to be 6. And then 5 to the 3rd is 125. X to the 6th. Same thing for K. Give that power of 3 to everything in those parentheses. So we have -2 to the 3rd power. 3 times 3 is going to be 9. And then multiply out -2 to the 3rd. If you're typing this in a calculator or on Desmos, whatever you're using, be sure to put parentheses around it because -2 to the 3rd, actually for odd powers you're okay, but for even powers it will make a big difference. So -2 to the 3rd is -8, x to the 9th. And it's okay if we have our negative here. That's fine. Remember, the only time we move stuff is if we have a negative exponent. Okay, so next one, I'm going to give my power of 4 to both. So I've got a negative x to the 4th. Now think about if it's a negative number being raised to an even power. Well, that's going to turn positive. So we're going to end up with a positive x to the 8th and y to the 4th. Okay, so a negative number raised to an even power will always turn positive. So that's how I was able to turn that to an 8. We're not multiplying -2 times 4. That's not what you're multiplying. It's like a negative x being raised to an even power. Okay, on M, I'm going to give both of these the power of 2. 2 to the 2nd power, that's going to be 4. And then I get n to the 6th because it's a power to a power. Now, I'm just going to bring this down, okay, and multiply these things because this part here did not have a power. So now I'm just going to multiply. 4 times 5 gives me 20. Now I add my ends. So remember, the ends, it's going straight across. Use a different color. So ends, we're going straight across. So remember, it looks like you would add those. okay? So we would get n to the 8th, and then there's nothing to add to the m, it's just m. Okay, so for example n, we want to take care of this first. So I've got 2 to the 3rd, power to a power we multiply, so it'd be a to the 6th, b to the 9th. And then I'm going to multiply that. I'm just going to bring this other part straight down, negative 3ab squared. Squeeze that in there. Okay. Well, remember, 2 to the 3rd is going to give me 8. So I'm just going to put an 8 over this so I know that that's an 8. So negative 3 times 8 gives me negative 24. I add my powers of a's, so I get 7, and I add my power of b's, I get 11. Okay, so now we're getting into some fractions. You can do this a couple ways. You can reduce on the inside first, or you can distribute that power. I like to reduce on the inside first, personally. So if I take care of my b's, b to the 6th and b to the 3rd, if I subtract those, I'm going to get b to the 3rd. And for c, 5 minus 2, I will also get 3. All right, now I'm just going to raise everything to the 3rd power. Power to a power we multiply. So we get b to the 9th, c to the 9th. And there's our answer. Okay. So then for this one, now what I have to do on this one is I have to simplify this bottom part first before you can start combining. So I have x to the 6, y to the negative 6 on top. And then if I raise everything to the 2nd power, we distribute here, x to the 6th, y to the 8th, power to power we multiply. Now I can subtract. So what happens to my x's, they cancel each other out. 6 minus 6 is 0. Anything to 0 power is 1. And if I subtract, so remember, you're doing 8 minus negative 6, which is going to be 14 because that double negative. And since it's bigger on the bottom, it's going to be 1 over y to the 14th. Okay, it goes wherever. Just subtract your bigger number minus your smaller number. Just subtract those. And then put it wherever the bigger one is. Okay? On Q, if I try to clean this up any on the inside first, I'll get A. So if I do 5 minus 3, I'll get 2, and it's bigger on the bottom, so I know N is going to go on the bottom to the negative 2nd. Now, a negative power also means my fraction is going to flip. So I'm going to rewrite it as 2n to the 2nd over A. And now my negative exponent goes away. I just flip my fraction, everything just flips. And now I'm going to give everything this power of 2. This 2 goes everywhere. So 2 to the 2nd power, so just think, we'll save ourselves a step. Well, it's 2 to the 2nd power? It's 4. And then multiply the 2 times the 2, we get 4 for n, and then a to the 2nd. Okay, for r, if we clean this up, so once again, reduce 2 over 4. Those are just whole numbers. So that's going to be 1/2. If I subtract 8 minus negative 3, I get 11. 8 is bigger, so I'm putting it on the bottom. And if I subtract my y, 6 minus 3 is 3. All right. Then I can flip that because it's a negative exponent. So it's going to be 2x to the 11th, y to the 3rd, And then that 1 was on the bottom, but we don't normally put fractions on the bottom. Okay, now we distribute this 3. Everything gets the power of 3. So we've got 2 to the 3rd, multiply 11 times 3 is 33. 3 times 3 is 9. And then one more step, 2 to the 3rd is 8. X to the 33rd, y to the 9th. Okay, example S. I've got to do the bottom first because it's got its own exponent. Okay, so, and actually since it's a negative, I'm going to move all of it up to the top. So that's what I could do. I've got 3b to the negative 6th, c to the 5th, and then I've got times 4b to the 4th, c to the 2nd, to the 2nd. Notice I made that new power positive because I moved it to the top. I still need to take care of doing this first though. So I'm just going to bring down 3b to the negative 6, c to the 5th. 4 to the 2nd power is 16. B to the 4th to the 2nd power, so that's going to give me B to the 8th. And then I'll get C to the 4th. So then I can multiply the 3 times 16, which is going to give me 48. If I add my B's, negative 6 plus 8 is 2. And add my C's, I will get 9. All right, and then last problem, one of the easiest problems on the page. Everything in parentheses is to the 0 power, so that is going to turn into 1. And we are done.